There's something deeply counterintuitive about the headline we're starting with today. In the middle of a global AI race where countries are competing on speed, scale, and supremacy, China, one of the most aggressive builders of artificial intelligence, does something unexpected. It slows down, not because it can't buy, not because the technology doesn't work, but because moving forward might lock it in too deeply. The headline reads, China asks tech firms to halt orders for NVIDIA's H200 AI chips. At first glance, this sounds like geopolitics or trade restrictions or another chapter in the US-China tech standoff. But that's not the real story. This is not a story about a chip being blocked. This is a story about a system that has become too foundational to exit cleanly. And to understand why this pause matters, we need to do something most headlines don't do. We need to go under the surface of AI itself. This is Built to Brand, a podcast about how companies, people, and ideas build belief over time, not through noise, but through inevitability. I'm Dhanvi, and in each episode, we take a headline, something that looks ordinary at first glance, and slow it down. Because sometimes a pause tells you more than a breakthrough. Let's first clarify what didn't happen. China did not ban NVIDIA. It did not declare the H200 unsafe. It did not say Chinese companies should abandon NVIDIA's technology. Instead, it asked some domestic tech firms to pause new orders. Pause. That word matters because a pause suggests hesitation, not rejection, evaluation and not retaliation, strategy and not ideology. And that immediately raises a deeper question. Why would a country that wants to dominate AI, that needs massive compute power, that has companies training some of the world's largest models, ask those companies to wait? To answer that, we need to dismantle a common misconception. Most people think AI progress is driven by three things: data, algorithms, and hardware. So when we hear AI chips, we instinctively focus on hardware, faster chips, more memory, and better performance. But that's only one layer of the story. Modern AI does not run directly on hardware, it runs on a stack. And the most powerful layer in that stack is not the chip. It's the software ecosystem that sits between the model and the silicon. This is where NVIDIA quietly won. Let's break the AI stack down simply. Think of AI like a skyscraper. At the top, AI applications, chatbots, image generators, recommendation systems. Below that, machine learning models, large language models, vision models, multimodal systems. Below that, AI frameworks, tools developers use to train and run models, names like PyTorch, TensorFlow, JAX. Below that, low-level libraries, the performance engines that handle math at scale. And only at the very bottom, the hardware, that is GPUs, accelerators, and memory. Most people assume the power sits at the bottom. In reality, the lock-in happens in the middle, and NVIDIA owns that middle. If NVIDIA only sold GPUs, this would not be a problem. China could buy domestic chips, accept some performance loss, and move on. But NVIDIA didn't just sell chips. It built CUDA. CUDA is short for Compute Unified Device Architecture. And that is NVIDIA's software platform for parallel computing. That sounds technical, so let's translate it. CUDA is the language AI systems speak to the GPUs. It's the layer that tells the hardware how to break problems into millions of parallel tasks, how to move data efficiently, and how to optimize memory and speed. Most AI developers never write CUDA directly, but almost everything they use depends on it. Now, here's what makes CUDA powerful. AI researchers write code in PyTorch, TensorFlow, and JAX. These frameworks, they assume CUDA, and their default performance paths are written for NVIDIA GPUs. They're tested on NVIDIA GPUs and optimized over years for NVIDIA GPUs. So when someone says, why doesn't China just switch to another chip? What they're really asking is, why doesn't China rewrite a decade of software assumptions? This isn't like switching from Android to iOS. It's like changing the alphabet your language is written in. Let's talk about training large AI models, the kind powering chatbots, search engines, and national AI systems. Training a large language model requires thousands of GPUs working in parallel, constantly exchanging data. This process is extremely sensitive to memory bandwidth, interchip communication, numerical precision, and software stability. NVIDIA dominates the space not just with the hardware, but software libraries like cuDNN, cuBLAS, and NCCL. These libraries are deeply integrated, aggressively optimized, battle tested at scale. Chinese tech firms have entire training pipelines built around this stack. Replacing the GPU is not enough. You'd need equivalent libraries, equivalent tooling, and equivalent reliability under stress. That takes years. Training gets headlines, and inference runs the world. Inference is what happens after a model is trained, when users interact with it, when it answers questions. Inference needs to be fast, cheap, predictable, and scalable. NVIDIA dominates inference through tools like TensorRT and Triton Inference Server. These tools compress models, optimize execution, reduce latency and cost. This matters because AI at scale is expensive. Margins depend on efficiency, and milliseconds and memory usage translates to real money. Domestic alternatives may work, but they often cost more per request, require custom engineering, and break under high load. For national scale systems, that's simply unacceptable. There's another layer most people miss. AI talent itself is trained on NVIDIA. University labs use NVIDIA GPUs, research papers benchmark on NVIDIA hardware, and open source repositories assume CUDA. This creates developer gravity. Even if a new chip is competitive, developers don't instinctively trust it. Tooling is immature, and documentation is thinner, debugging is harder. So adoption slows not because of ideology, but because of friction. This is not a technical failure, it's an ecosystem gap. And ecosystems, they take decades to build. Now, let's bring the H200 back into focus. The H200 isn't just faster, it's designed for massive memory workloads, transformer-heavy architectures, and scaling across thousands of GPUs. It strengthens NVIDIA's advantage at system level. Adopting it doesn't just improve performance, it deepens architectural dependence. From China's perspective, that's the risk. Not short-term capability, but long-term exit cost. So when China asks the firms to pause orders, it's not hesitating about NVIDIA's quality. It's hesitating about how deeply NVIDIA is embedded. Because once your models, your tooling, your developer culture, and your inference economics are built around a single stack, leaving is no longer a technical decision. It's a strategic one, and that's where this stops being a chip story and becomes a build-to-brand story. In the last segment, we stripped the headline down to its foundations. China didn't pause because NVIDIA's chips aren't good enough. It paused because NVIDIA's stack is too good, too embedded, too assumed, and too difficult to exit once fully embraced. We talked about CUDA not as code, but as the invisible language of modern AI. We talked about training, inference, and developer gravity, and we ended on a moment of tension where dependence becomes deep enough, progress itself starts to feel risky. So now we zoom out because what's happening here isn't just about AI infrastructure, it's about how power is built in the modern world. And increasingly, that power doesn't wear a flag, it wears a brand. Let's return to the specific chip at the center of the story, NVIDIA's H200. On paper, the H200 is a technical upgrade, more memory bandwidth, better performance for transformer models, and higher efficiency at scale. But strategically, it does something more important. It pushes NVIDIA's advantage up the stack. The H200 isn't just faster hardware, it's designed to work best when models are trained using NVIDIA's libraries and systems are orchestrated using NVIDIA's software. Clusters communicate using NVIDIA's protocols. In other words, it rewards those who are already deep inside the NVIDIA's ecosystem. From China's perspective, this is the danger zone because adopting the H200 doesn't just accelerate AI development, it raises the cost of ever leaving NVIDIA behind. And this is the moment where infrastructure turns to dependency. NVIDIA didn't build this position through advertising, it built it through early investment in developer tooling, relentless focus on performance libraries, and making CUDA the default assumption in research. Over time, NVIDIA stopped being perceived as one option among many and became the safe, expected choice. That's not persuasion, that's infrastructure psychology. People don't question roads, they don't question plumbing. They only notice them when they fail or when access becomes uncertain. China's pause suggests NVIDIA has reached that level. Now, let's talk about who really carries NVIDIA's brand. It's not executive, it's not marketers, and it's not the customers. It's actually the developers. AI engineers build mental habits, how they structure models, how they debug performance, and how they interpret benchmarks. Those habits are shaped by CUDA tutorials, NVIDIA documentation, and NVIDIA defaults. Over time, this creates something powerful, a generation of builders who don't just use NVIDIA, they think NVIDIA. And that's brand penetration at a cognitive level. And once that happens, switching costs aren't measured in money, they are measured in time, confidence, and risk. Now we reach the heart of the episode. At some point, brand dominance flips. What once felt like safety starts to feel like exposure. From China's strategic point of view, relying on NVIDIA accelerates AI capability, but it centralizes a critical dependency outside national control. This isn't paranoia, it's a rational risk assessment because brands can be disrupted, supply chains can be restricted, policies can change. And when a brand sits at the core of your AI infrastructure, those changes ripple outward. And the stronger the brand, the bigger the blast radius. To understand NVIDIA's position, it helps to compare it to other quiet giants. ASML controls extreme ultraviolet lithography. Without it, advanced chips can't be made. ARM designs instruction sets that power billions of devices. You don't see ARM, but everything runs on it. Apple controls ecosystems through integration, not specs. These brands don't shout, they structure reality. NVIDIA now belongs in this category not because it sells GPUs, but because it defines how AI computation is done. This is why the story belongs on Build to Brand, because NVIDIA shows us something profound. The most powerful brands today are not built through storytelling, they are built through systems people forget to question. CUDA isn't a logo, it's an assumption. And once your brand becomes an assumption, you stop being chosen and you start being depended on. That's the highest form of brand power and also the most dangerous. China's pause isn't about slowing down AI. It's about asking a difficult question. How much progress are we willing to trade for control? That's not a technical question, that's a strategic one, and increasingly, it's a branding one. Because in a world where software shapes reality, brands don't just influence markets, they influence futures. This episode of Build to Brand wasn't about chips. It was about what happens when belief hardens into infrastructure, when the tools we trust become the system we rely on, and when walking away becomes harder than moving forward. Because the strongest brands aren't the ones you admire, they are the ones you hesitate to lose.